Good morning. Good morning. So it is a few minutes late. Agree. Still also I will ready for yes 7:40. 10 minutes delay, but your attendance should be very low. Now 70. So that's why I am waiting for that. Okay. Today I will. This is a very important one. Tuesday also we will do. Again, calculate this calibration of seed drill. What is the calibration? So Tuesday we will see spray calibration. Now Seedar calibration, and I will give you 2 questions for you. Today we will, and Tuesday I will do that also. Right? Today we will see the calibration. What are the parameters? So the calibration, it is the procedure to test seed drill for correct seed drill. Seed drill is the mission. Seedar. Seed drill is called Seedar. For correct seed rate. Seed rate means how many kilogram seed for particular land area. It should be hectare or something, right? Hectare. It is necessary to calibrate the seed drill before operating in the field. When you test the field test before you want to test in the lab. That is the meaning. It is necessary to calibrate. Calibrate is a lab testing. The seed drill is a machine before operating in the field, right? Number, there are no dimension. S should be in meter. Meter, number, then you will find out the width of drill. Okay? So next one. Find the length of stick. Yeah. Yeah, very simple. Determine the normal width of drill. How many width the seeder should be? I told you seeder have one seed tube or one furrow opener and develop 3 or 4 or 5 like that. So when your furrow openers are 3 or 2 or more than 3, how can you calculate width of drill? How many width it will be in one operation? Sometimes 3 seeds will fall down. So you want to know what is the spacing between the furrow opener, because seed will when the furrow opener, seed will fall down on the furrow opener. So they have a between spacing also there. That is why number of furrow opener m multiplied by what is the spacing between the furrow. Otherwise, sometimes we call number of seed tubes. That's also same. What is the distance between seed tubes? Right? It called width of drill. Right? This is step 1. Step 2. Find the length of strip. Having normal width necessary to cover 1/25 of hectare. So what's here? Lot of digits are there. Hello, so many numbers, dividing everything there. What they told you? Ask 1/25 of hectare. You want to divide 25 parts in 1 hectare. You want to know how much of meters at 1 hectare? 10,000. That's why 10,000 is there. Why? all are in meter. So you want to change hectare to meter 10,000. You want to divide in 25 parts. That's why divide into 25. Right? 10,000 divided into 25 because they asked into 1/25 hectare. When you divide into 25 parts in 1 hectare, so 10,000 divided by 25, you divide by width. You can find out the length of the strip L. Okay, very simply what I want to tell, length and width is equal to coverage area. Length and width. How do you cover? Length and width are needed to calculate the area, covering area. So length and width is equal to L into W equal to 10,000 divided by 24. So that is why you will see L equal to 400 divided by W. 10,000 divided by 25 is 400. So with length of cut, length of strip is calculated by area 400 meters square divided by width cut in meters. So that is the, you can find out length. Determine the number of revolution. The ground wheel, it is a very difficult step. So wow, okay, I will ask you, suppose D diameter wheel rotate in a n times. This is called how many number of times? Rotation. So per minute, call rotation per minute. Pi is there? Why pi is there? This is round wheel. Normally all the Seedar wheel are round. So this is called ground wheel. Ground wheel always round. When the round wheel is moving one time, the length of the travel should be pi dn. Pi dn means length of the travel. Right? Pi into d mean peripheral length. Pi into d mean peripheral length. So normally peripheral length calculated by 2 pi r. 2, then 2 pi r is equal pi into d. 2 pi r equal to pi into d. So it is the number of revolution. Then it is the total length of travel during the n rpm. This length of travel equal to, you see this also a length of travel. 400 divided by w. Then n should be calculated. Suppose if you don't know n, how many revolution rotation needed, calculated by 400, then you want to divide this pi d in the bottom, 400 over w into phi d. This is called rpm. How many revolution needed, determine the number of revolution the ground wheel has to make to cover the length of the strip L. Right? So the 4, raise the seed drill in such a way that ground wheels turn freely, make a mark on the dry wheel and corresponding mark at the convenient place on the body of the drill to help in counting the revolution of the dry wheel. So here what the thing is, there ground wheel have a chain. Will have a chain, or sometimes ground wheel axis have a wheel. The chain is coupled to the seed metering shaft wheel. So rotation speed of the metering device. So what the thing is, the ground wheel is connected the metering, the seed metering device shaft. The ground wheel is rotating, then metering device also rotating. Then these two shafts are interconnected by chain. So that is why you now the question metering device rotational speed. They are asking the metering device rotational speed of the speed plate divided by distance. So here what the circumference mean traveling length pi into. So this is why 2 into there r is given. Here r is given 0.3 meter r. 2 pi r is equal to 1.885 meter. Determine the distance with considerable percent sleep is there. So what the thing is there? If you move the seeder in the field, sometime wheels should be slip. So the 5% slip mean you 100% is 1.885. Now the wheel is working 95% because the 5% is slip mean 5% is drop. So that is why 1.885 meter now 1.79 meter actual traveling length. Actual traveling 1.79. In theoretical it should be 1.885 meter want to travel. But in sometime field should be muddy, sometimes stone, sometimes they are not fat. So the traveling length should be low, 0.79. The number of seat per revolution. What is one revolution of the seat plate? How many seat will be fall down? Or otherwise, sometimes this call the how many revolution mean one rotation of the ground wheel. How many seats will fall down? This is the question line. The number of seats per revolution. What is the meaning? One revolution of the ground wheel, how many seats fall down? So distance divided by seat spacing. So distance, suppose this will travel 1.7 meter. Seat spacing is given 0.15 meter. Every 0.1 meter, one seat want to fall down. Every 0.14 meter, one seat should be fall down. So total length divided by this length, then how many seats fall down in one revolution? It's called 13 seats. According to this calculation, it should be 13 seats for one rotation of the ground wheel. Determine the speed of speed plate. Determine the speed of speed plate. Speed plate and the ground wheel are not rotate same speed. There are some difference there. So 13 seats. Why divide by 12? So this is the speed of the Seedar. 7.2 kilometer per hour we will give you. Hello, we will give you. So what the thing is there, actually this is the question not given to you. So 13 seats want to fall down, right? That's a seat plate having 12 holes. Hello, seat 13 seat want to fall down. Compulsory by the calculation, 13 seat want to fall down, but 12 pockets are there. 12 seat holes are there in one plate. So 13 divided by number of holes in the seat plate divided by velocity. Hurry. So there you will find out 1 hour how many meter. Normally you will see speed should be meter per second. Meter per minute, meter per hour also you can write it. So this is the seat plate speed. Therefore, rotational speed. So this is the velocity. 1 hour it will travel 7,800 meters. What is the meaning of this speed? 1 hour it will travel this. So 1.7 meter, how many? So one revolution, 1.7 meter is there. If it is one rotation, it will travel 1.7 meter. So this is 1,800 meter, how many revolution needed for 1 hour? So how you divide into 6, it should be minute. So if you did properly, you see RPH per hour, divide by 60, 72.63 RPM. Seed metering, rotational speed of the seed metering seed plate should be 72.63 RPM. This is the question answer. This also want to be calculated, the speed and the number of cells in the plate, everything given to you. Don't worry. Are also given to you. So I will move and I will tell you. This is the some calculation. All the values are given to you. You want to multiply and find out. So I will give you this. Already you write these two. You see spacing between row, diameter of the land ground wheel, RPM of the land wheel, seed collect tempo of the trial, 30 kilogram. Maybe it should be in hour. The question seed rate. Okay. So we will move. Some other calculations are there. Okay, determine the flow rate of seed. That is the kilogram per hectare. Flow rate or seed rate is calculated. Q is the flow rate feed from the metering unit. So this is the flow rate mean how many seeds. Actually, so here is a flow rate mean number of seeds from one. So sometimes here why they put length of a circle. So you know the length of the seed metering device, then you know how many seeds will fall down. So here one equation Q is RS. RS. What is RS? Seed rate. How many seeds per hectare? Seed rate is multiplied by spacing between rows and multiplied by dual speed. This is the velocity. Velocity is spacing seed rate divide by 10,000 because of it should be in a hectare. RS is in hectare. You divided 10,000, it should be meters square. And the density also here take into account. You want to divide by density. You see, seed belt density. Kilogram per one length. 1 meter. Suppose 1 meter spacing of the seed tube, how many kilograms seed will fall down? It density. Density normally you will measured by kilogram of volume. Here volume is not taken. This traveling length is taking the account this traveling length. L is this traveling length is near to same as volume. So kilogram over L. So this is also you want to keep on your mind. What is there? Q is there. How many flow rate of seed metering device? Hello, RS is a seed rate. This is a seed rate or flow rate of the seed plate or seed metering device. Flow rate of seeds from the seed metering units. Right, Q. Very important parameter. Flow rate or how many seeds for one length. L over S calculated by this equation. So next one we will see. So calibration of seed drill, weight of the quantity of seed collected in the container and record the observation. So calculate the seed rate kilogram in one. So how they will be calculated seed rate. So you rotate the wheel in a 100 revolution. You rotate and collect the seed. Right? Then seed rate will how they calculated for this 400, why they divide into 400, 1 over 25th. Oh, otherwise what is the kilogram? 10,000 divided by 400 into seed rate kilogram per hectare. Right. Here what the thing is there, why 400 is there? Why 400 is there? Hello. So actually one acre should be 4,000. Hello. 1 acre should be 4,000. Seed rate is given kilogram per acre. Now the question kilogram per hectare. Then divide by 4,000. Actually it should be in a kilogram. See, that's why this 400 is coming down. So it should be kilogram per hectare. Actually this should be a 4,000. I will tell you later. But 10,000 into C, actually C is given to you kilogram per acre. Seed rate is given to kilogram per acre. Now we ask the question, seed rate per kilogram per hectare. Then divide by 4,000, multiply by 10,000. Right? So design the metering mechanism. This is also a very difficult task. I told you. Travel of this seed plate is pi dn. So the n is calculated, number of revolution is calculated, velocity divide by pi d into 60. Why 60? Minute. Number of revolution per minute. Sometime number of revolution given to second or hour. You want to divide it or multiply 60. Depend on the given parameter. Suppose hour dividing. Suppose meter per second velocity is a meter per second. You want to meter per minute. Revolution per minute. You want to multiply 60. Why? Velocity in a second multiplied by 60, then you will get a minute. The velocity is equal to, actually velocity is equal to pi dn. Pi is a constant diameter and revolution per minute. Revolution per minute divided by 60 is equal to V over pi d, then 60 multiply here, you will get it, number of revolution. So write down this equation also. Velocity over diameter of the ground wheel, pi d, and multiply by 60. So here what the thing is now in number of cells on metering disc or roller. Number of cells, I told you earlier on 12, number of cells on roller. 12 I told you number of cells, earlier calculation I will told 12 number of holes are there in plate. This is the one, small n, number of cells on roller. Ground wheel diameter, required speed, seed spacing, gear ratio. Why gear ratio now come to the why gear ratio is I told you ground wheel and the seed metering wheel are interconnected by chain. But we don't know number of teeth. Wheel is meaning round material having teeth. Sometimes your ground will have 100 teeth. Your seed metering device after having 10 teeth, teeth ratio should be 10. 100 versus 10. 100, 100 teeth and the 10 teeth, teeth ratio should be 10. So here, gear ratio also I is important. Then you put gear ratio 10, X is a seed given to you, pi into d diameter is given to you, you will calculate number of cells. So otherwise we will give you number of cells and surely diameter and surely X. You want to find out what is the gear ratio. What is the gear ratio needed? Then you put that. Because gear having 3 set of wheels. So ground wheel only 1 wheel. The meter device have 1 or 2 wheels. Gear ratio. So gear ratio will find out. N is given, number of cells is given because seed plate is already designed. You know number of cells. Diameter of ground wheel you know you measure. X is given to you, seed spacing. Then you will find out what is the gear ratio of the gear ratio needed for this operation. So we will ask you this question also. Here one is dr is over vr into pi into nr. So dr is diameter of the seed roller. So now the question, seed device have seed plate. This what is the diameter of the seed plate? That is the dr. Peripheral velocity needed meter per minute. So number of revolution nr. Number of revolution pi into velocity of the particular disk. Is the disk diameter. This is the diameter of the seed metering disk. Seed metering disk diameter. Very simple. You will multiply in the bottom. Pi d n is equal to vr. Velocity is equal to pi diameter into number of revolution. So dr is equal to vr over pi into nr. Here nr is defined rpm of the roll. A fluted seed drill has 8 furrows. Okay, now you see number of furrows. Openers, single disc type. The furrow openers are spaced 30 centimeter apart. Then you know plant spacing 30 centimeter. The main drive wheel has diameter 190. How many turns of main driven wheel, ground wheel, when the seed drill has cover 1 meter of area? So coming Tuesday, whatever the way you want to solve this and tell me the answer. Hurry. So the next one, determine the seed rate by the seed drill from the following field calibration exercise. The following data were collected. So actually, you will take 30 kilogram per minute because RPM is minute. So for the 800 rotation, 800 rotation, 30 kilogram will receive. 800 rotation, they will collect 30 kilogram of seeds. So no need minute or hour or whatever, 30 kilogram, this is enough data. So you want to tell coming Tuesday, I will check this. Sometime I will call you and ask answer. Then I will put assignment marks. I will randomly ask you a question. Okay, wait a minute, I will check. Hello. Hello.
Yes, sir.
Okay, write down these equations. Normal width of C drill, W is equal to MS. What is MNS? I will give you 2 minutes for each side. You write down the equation. Okay, one. I will click after the 2 minutes. Right. First one, normal width of drill. Uh, so that is the same as the second slide. So write down this. Write down. 2 minutes I will give you. Hello, sometime feet, then you will tell it meter. We will normal inch. Everything we will give you meter. Don't worry, this is the equation. Write down very quickly. Up to 3.14. What is the 3.14? Pi. Pi is 22 upon 7. Right? You will put 22 upon 7 or otherwise 3.14. Common name. Okay, write down this also. This already you have. Right? So you write this equation. $73.6. Hello? Hello?
Yes, sir.
So, for this calculation, the following results were obtained while calculating seed drill. Calculate the seed drill per hectare. Number of furrows 8, spacing 15, diameter of the wheel 1.5 meter, RPM of the driven wheel 600, seed collected 25. Same as the question previous. But this answer was not other one. This is the question. Answer was 73.6 kilogram per hectare. This is the answer. If you want, you see, this is the way. 73.6, correct. But I will not give you that slide. You will do the previous one. 800 RPM, 30 kilogram. So tell me the correct answer. This is the answer of this question. You know which way you want to do it. I will not do. So this question I will do on Tuesday. That same day you want to tell what is the answer for previous question. There are two. This is problem 2. Problem 1 also. There are two problems in first assignment. That is seed collected 30 kilogram, RPM 800. So for problem maybe 8 or 9 or something. This is the answer for this. If you did properly, so this is the question I already give you, right? Okay, this also you already wrote, right, in the slide. This already you got it point. So what is this seed planting machine on it? Okay, rest of the thing I will solve on Tuesday. Please come with the answer of these two first two. So you have a marks, assignment marks. So now 8:30, near to 8:40, I will stop it here. Okay, we will meet on Monday. You are free? Monday? Today we will start on the machinery. Hello? You are free on Monday? 1 o'clock? 2 o'clock? Hello?
Sir, 1 to 2. Okay, sir.
Okay. Then we will do 1 to 2. 1 to 2:30. Okay. You have a practical evening?
Yes, sir.
2 o'clock.
Yes, sir.
Then 1 o'clock. 1 o'clock. Machinery. Fuel system of transmission. Okay. 1 o'clock tomorrow. Oh, sorry, not tomorrow, Monday. Sunday, no class. You are free, yeah? Sunday, I will not do. Okay? Monday, 1 o'clock. Tuesday, 10:30 to 12:30. Wednesday, 9. Thursday, 9. Friday, 11:30. Okay? So, we will meet on Monday, 1 o'clock.